Welcome to this session. This session we discuss about frictional force. And frictional force is simply a force which opposes motion between two rough surfaces. So it's an opposing force. And what we call maximum friction or limiting friction between two surfaces is given by the formula mu times r, where mu is what we call coefficient of friction, and r is what we call the normal reaction force. So for frictional force to act, then two surfaces should be moving relative to each other, or two surfaces should be tending to move, should have a tendency to move relative to one another. So to find what we call the limiting or maximum friction, we use this formula in this equation. So we have a problem here. A particle of mass 5 kilograms is pulled along a rough horizontal surface by a horizontal force of magnitude 20 newtons, and then the coefficient of friction is given by 0.2. Remember, the coefficient of friction has no units. So there are two questions. First, to find the magnitude of the frictional force, and then the second, to find the acceleration of the particle with this motion. Now, the best thing to do in such a problem is to draw a sketch. So let's draw a sketch. So we have, let this be the horizontal. So we have the particle here. So being told that the particle of mass 5 kilogram is pulled along a rough surface by a horizontal force of magnitude 20 newtons. So let's show the force of 20 newtons acting on this particle. And then calculate the magnitude of friction force. So remember, frictional force, if this is the motion where the object is being pulled, then frictional force acts in the opposite direction. So this is where the frictional force will be acting. So let's write Fr to mean frictional force. Then we have the mass of the object is 5 kilograms. So 5 kilograms means the weight, which is mg, so which is 5 times 9.8, and 5 times 9.8 is given by 49. So the weight is 49 newtons, and the normal reaction is actually a force acting perpendicular to the surface, and in this case, opposite to the weight. So this is the normal reaction, R. So to find the value of the frictional force, the assumption is that this system or these four forces are at equilibrium. So horizontal forces or vertical forces, let's start with vertical component. So we expect normal reaction to be equal to the weight. So we have weight, which is mg, so which is given by 5 times 9.8, which is 49 newtons. And then, since frictional force is given by mu r, then this will be mu, which is 0.2 times r, which is 49, will give us 0.2 times 49, which is 9.8. So therefore, the frictional force is 9.8 newtons. And then acceleration, the second part. So horizontal forces. So the total net force in the horizontal direction should be the same as MA. But then in the horizontal, then we use sub x to mean horizontal. So this will be 20 newtons minus the value of the frictional force, because this is acting in the opposite direction. So we'll have 20 minus 9.8 should give us mass of this object, which is 5 times the acceleration. So 20 minus 9.8 will be 10.2 equals to 5x. So that means acceleration will be 10.2 divided by 5. Dividing this by 5, we get 2.04 meters per square second. 2.04 meters per square second. So that is the acceleration. Thank you.